All counting methods are based on something known as the fundamental counting principle that says to count the number of ways an event can happen, you multiply your number of choices together. So for some basic simple problems, here we go. If we have 4 flavors of ice cream, that's 4 choices, 3 sauces, that's 3 choices, and 5 toppings on a table, how many ways could you make a sundae that uses one of each? Well, you have 4 choices of ice cream, 3 choices of sauces, and 5 choices of toppings. And so you have 4 times 3 times 5 choices. So you have 60 choices, 60 different sundaes. Of course, if you could pick more than one, it gets more complicated, but there it is in basic. Or something like this. If you need to set a 4-letter combination for your lock, how many different combinations are possible? So you have a choice for each letter, and you have 4 letters. So then the question is, well, how many choices do you have for a letter? The alphabet has 26 letters, so you have 26 choices. And then you have another 26 choices. And then you have another 26 choices. And then you still have another 26 choices. Because no one's saying you can't make your combination Z, 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 Z. You can use the same letter more than once. So we multiply 26 times 26 times 26 times 26, otherwise known as 26 times itself 4 times. So 26 to the 4th power, which is going to be 456,976 different combinations possible. Okay, and then here we go. What if it's a 4-digit combination? Numbers, not letters. How would that be different? Well, it's still 4, so we're still going to make 4 decisions. But this time it's only a digit, meaning it's a number 0 through 9, a single-digit number. If you count the 0, that is 10 choices. Use your fingers to prove it to yourself. So you have 10 choices for the first number, 10 choices for the second number, 10 choices for the third, 10 choices for the fourth, otherwise known as 10 to the 4th, which is 10,000. So with fewer choices at each stage, you get fewer combinations possible when you multiply all your choices together. That implies that you can make your combination be 0, 0, 0, 0 if you wanted. If you did not want to repeat, you would have to lose a choice each time. So you would have 10 times 9 times 8 times 7. Okay, moving on. A little fancier types of combinations are called permutations and combinations. A permutation is an arrangement of selected items. Where changing the order of the items changes the meaning. For example, if you had 3 runners and the same 3 runners finished in a different order, first place, second place, and third place, it would mean something different. Obviously, the first place winner would prefer to be first place, not second or third. The symbol we're going to use for permutations is this N, little n, big P, little r, NPR. The N is the total number of items. N for number. Total number that we're picking from. And R is the number that we are going to arrange. If we're going to line up 5 things, then that would be our R. The number that we arrange is the R. That's the symbol we're going to look for in our calculator as well in order to do the problem. In the TIs, you're going to look for your math button. In the Casio, and then you're going to have to arrow over to the probability PRB list in order to find NPR. as your symbol. On a Casio, you're going to hit the option button, which is OPTN. And then you're going to arrow over by pressing F6. And then you're going to see probability as F3. So then you're going to do F3. All right, and then you will see the NPR and the CR that we're about to talk about there. Okay, so permutations are arrangements, putting things in an order. Combinations, on the other hand, are groups of items, where the order that the items are listed in does not impact the meaning. For example, toppings on a pizza, the order that you say the ingredients in when you're putting them, talking to the person ordering your pizza on the phone or clicking the buttons on the online ordering doesn't change what the pizza looks like when it comes. Alrighty, so a group when order doesn't matter. Other groups besides toppings on a pizza would be things like committees, people working together to do the same job, people winning the same prize. 5 people win a gift card of the same value to the same store. The symbol for combinations is an NCR. The numbers basically mean the same. N is the total number again. R is not the number that we arrange, it's the number in the group. It's the group size. If we're going to make groups of 5, then R is 5. All right, let's try some examples. So first, deciding if it's a permutation or a combination, an arrangement or a group, and then typing it into the calculator to calculate it. So if we have 8 teams in a baseball tournament, and how many ways could the teams be listed in order in the program? Order. Order makes it a P. Permutation. Okay, so we need the total number. Okay, there's 8 teams. And we're going to list the teams. So we're listing all of them. So we're going to put 8 teams in order. So that's going to be the same number, 8P8. So that's what we do in our calculator. We type the 8, then we press our NPR symbol, and then we type our 8. Again, the NPR symbol in your TI is in the math button, and it's in the options in a Casio. The great thing about the Casio is the symbols stay on your screen once you find them. On the TI, you're going to have to go through that math and over to probability every time. Okay, the next one. There are 7 types of cookies on a platter, and how many ways can you choose 3 types to eat? Okay, so is that a first, second, and third situation, or is that just a group of 3 cookies? Since we're not ranking them, that's just a group of 3 cookies, so we would make that be a combination. The number we could pick from was 7, and the group size is 3 cookies, so 7C3. Type your 7, press the NCR, press the 3. 35. Nine people arrive at the escalator at the same time, and how many different orders can they get on the escalator? Order. So P, permutation. Total people, 9. How many people are we putting in order? 9. So 9P9. 362,880. Okay, final one here. You have 6 homework assignments to complete over the weekend. However, you only have time to complete 4 of them on Saturday. And how many orders can you complete 4 assignments? Orders. Because it said order, we know it's a P. How many did we have total? 6. How many are we lining up? 4. So 6 NPR 4 in our calculator, 360. Okay, last ones. You're picking 7 books from a stack of 32. If the order of the books is not important, how many different 7-book groups are possible? Groups. Groups are combination. How many could we pick from? 32. We're picking 7 of them. So 32C7. I believe that's 3,365,856. Okay. There are 12 volunteers, and how many ways could a team of 3 be chosen? Team. Team's just a group. So that would be a C. It doesn't say that they're doing different jobs, so we would pick from all 12. We would just get a group of 3 people. 220 ways. 220 possible groups of 3 to work together for that job. How many different ways could the leader and a publicist be chosen? Oh, well, that's 2 different jobs. If you have 2 different jobs, then order matters. Because even if the same 2 people are picked, they would be, if they were picked for a different job, they would be doing something different, and so order matters. Who's the leader and who's publicizing. So if you have different, always use permutation. Different jobs, I should say, not the word different. You have 12 people you're picking from, and you want to pick 2 of them. You want to line them up though. First person leader, second person publicist, or vice versa. So 12 NPR 2 is 132 different ways to get a leader and a publicist. Okay, if you have questions about your calculator or about choosing permutation or combination, or when you just multiply, please ask in class.